Okie dokie, let's see. All this stuff set up. Yeah. Wait a little bit, of course, for folks to stream in here. Open up participants. And make sure my audio is configured properly. 1 minute. Let's see. Let's see. What you doing, Zoom? There we go. Nope, that's good. Okay. Ooh, my throat today. Feels like it's been an abnormally long time since I last did anything for this class. I got my second vaccine dose on Thursday last week, and despite having read all of the things online about sometimes how bad it can be, I was not prepared. I lived in a terrible warp of like pain and shivering and sweat for a solid 2 days there. And it seems like it's been like a week since the last lab rather than, or not last lab, but about Wednesday rather than 4 or 5 days. But yeah. Okay. No, well, it's probably much better than the alternative. My two of my roommates are currently suffering in their own way with it, though I don't think as bad as I got it. I got it unusually bad. My partner didn't get it quite as bad as me, but it's still pretty rough. It's nothing like when you have like what is it, like 3 weeks to have a dissertation completely done and just lose 2 days out of nowhere. So it goes. That is the life of the graduate student. Yeah, so anyway, let's go ahead here and get moving. So this one is a template-based homework like the prior homework. It's actually a shorter one and it uses clean data, but the trick is that it's going to force you to do some complicated things that people tend not to find easy, which is actually writing compact, efficient code for iteration rather than just sort of manually doing stuff. So the easiest way to sort of handle and get started on this homework is, I again apologize for the size. My resolution is a little large here. The thing you want to do is download the homework template and probably put it in its own folder for like homework 6. I just have it in a generic folder right now for today. So you got homework 6, and then you'll download a zip file called Open Data Year 1 from the website. So if I have a convenient opening of the website over here, yeah, I can bring it up here. So you're essentially just going to go to the writing functions section. The writing functions section, you will download the template here, sort of right click, save link as saved on your computer. And then you also want to grab the Pronto bike share data here. This is like a 76 megabyte file. So, maybe don't download it on your cell phone or something, but otherwise it should be pretty trivial for any real internet connection. But if you are somewhere remote and on a slow connection, be warned about that, especially considering most of it, as it turns out, is wasted space. So you'll download the zip file from there, open it here on your computer, and then we will extract and basically pull out these files here. So you can basically, for instance, on Windows, right click and then hit extract and pop them out there. You want them extracted into a folder for instance, open data year 1, or just the loose files in the same directory as your RMD. I prefer to put them in a folder, and that's what I'm going to be expecting you'll have it set up as. So you should have a folder that looks something like this. It should have station data, status data, trip data, weather data, and a README file. And notice here the status data is a 850 megabyte Excel spreadsheet. That is a CSV sheet more specifically. The funny thing is we're not actually going to use that one. So if you're low on space on your computer, you don't want to eat up nearly a gigabyte, you can delete that and you'll have to make only minor changes to the script we're going to do. I'm just going to continue on as if you have the 850 megabyte waste of space sitting there just to show kind of subsetting and loading in data. Okay, so that's the sort of basic setup for this. If you have any issues with any of that, you let us know. Okay, so we got a template. You'll want to fill in all of the appropriate fields up here, which I'm not going to mess around with. You can see I haven't edited this homework assignment seriously since November 7th, my birthday, 2018. So hasn't been messed with. Okay, so the gist of this. This homework assignment is about playing with data from Seattle's old Pronto bike share program. So you've probably seen the iterations of like Lime bikes, Uber bikes, all these different bikes we've had over the last few years. Well, I think the first bike share system Seattle got seriously was the Pronto system. It was a docked bike share system. It was a bike share system that you had to pull the bikes out of these docking systems, which are essentially big bike rack systems. You check them out. And then when you ride the bike, you have to leave it at another one of the docks somewhere in Seattle. So there were docks all over the city. Well, the way the Pronto system worked is they tracked everybody's use of the bikes and they could figure out where people were going. That is from point A to point B based on what dock you checked your bike out at and what dock you dropped it off at. Right? It's a common bike share system. It's very common in other countries. Mexico City, for instance, their main bike share system is sort of a docked system like this. A lot of cities use these docked systems. Anyway, Seattle had one for a while, but it didn't work out, I guess. They shut it down after like a year. Anyway, these data here have been used for some online like data science competitions and stuff. So you can download these data for your own use. So they're available off of my website here, or you can pull them off of the Pronto Cycle Share. I think it's still there, but it might be better to pull it from like the Amazon link down here. Okay, so you'll pull those down. You'll extract them like I showed earlier. And then we're going to do some stuff with them. Okay, so what we want to do first is we want to get these Pronto bike share data into R so we can do some stuff with them. The thing is we don't actually want to use every one of these files because like I said before, one of them is an 850 megabyte waste of our time. And so we're not going to load that in. We also don't want to attempt to load in the readme.txt file. So what we're going to do is we're going to attempt to programmatically get all of the names of these files out of the directory and then read them in appropriately using loops and an apply statement and a vroom. Well, actually, we're not going to use a vroom statement here, but we'll use that and apply. Okay, so the first thing to do here is we're going to use a command I've only used a little bit in lab called list.files. So if you do something like getwd and run getwd in your markdown, your getwd command here is going to show you the current directory that the RMD file is looking for files in. By default, in an RMD file, it will look in whatever folder the RMD file is in. So in this case, it's looking at my lab folder right here where I drag all the docs for these labs. Well, if instead of getwd, you say list.files, list.files shows you all of the files and folders inside that current working directory. So rather than displaying what directory you're in, it displays the files and folders in it, which is, as you can see, exactly what we do here. If I show you the lab folder on my computer, you'll see it contains a homework6.rmd, opendatayear1.zip, and opendatayear1, which is just the folder. Okay, so list.files amazingly conveys the exact same information to us that a browser or Explorer window does on your PC or Mac. Okay, so the thing is, the files we want are inside that folder. If we want to tell list.files to show us files inside a subfolder, we can give it the name of that subfolder. You'll often see me type it this way. Instead of just typing the subfolder, I typically type dot period, open data year one. Open data year one. If I do this, it's going to show me the files inside. If I don't put the dot and period there, it's going to do the exact same thing. So you might be like, why does Chuck always put the dot period there? If you're an older school person, it's because Chuck likes to type things like their Unix file paths, and it used to be that it was a little bit more important to do relative directories by saying, what the period says is start at the current directory, then browse upward to open data year one. Most of the time, you don't actually need the dot period, but it becomes useful because it lets you remember that if you just type, for instance, is it just dot slash here? Dot slash will return the current one. Dot slash will browse up one more folder above where you're at. So dot is current directory. Dot is a directory up. I always like to use dot slash because it reminds me I have the option of doing dot slash to move up another directory. Okay. Just something I like to do. Okay. Sometimes, rarely, you'll encounter software that's real old school and requires the dot slash to signify that you're looking within the current directory. It's pretty rare nowadays, though. OK, so we see our files here. OK, so how would I assign? So I'm going to first take what we want to do, right? We want to get a character vector of all the files that are in this folder, specifically that we want. So I said before, we don't want readme.txt. It's not a data file. It's a readme for the data. We also don't want statusdata.csv because they suck. Okay, so if we want to keep those two files out of there, and we want to assign this to files in year one, how might I go about doing that? You can do either of these things. How would we assign these file names to files in year one, or how would we get only the things other than readme.txt and status data? No ideas. I like this homework assignment. It's a very short one, so I can make sure to solicit every answer slowly and painfully from everyone in the lab. So there's two steps here. First thing, how would I assign these file names, open data year one, to a thing named files in year one?
I have a question.
Here, let me turn my volume up. What you got?
So the list files shows what's currently in the working directory.
Yep.
And are we saying that we want something that's going to be called open data year one? Like that doesn't currently exist. So we want that to exist?
So are you saying, so list.files, this has to exist for list files to browse into it. So if I just do list.files, there must be open data year one for me to then browse into it and display the files inside it.
So what we're trying to do is create that open data year one in our working directory so that it can open that?
No, what I'm doing instead is this should be here. So if you do list.files, there should already be an open data year one, which contains all those files in it. Instead, what I'm trying to do is extract the file names and assign them to files in year one so that I can use those file names in like read.csv to read the files in. Does that make sense?
I see. Okay. I copied the individual. I didn't copy the entire folder into my work. I just took the individual data files. So that makes sense. That's why I was confused.
Oh yeah, yeah. If you've got them not in the folder, list.file shows you exactly what you want. Right?
Okay.
Yeah, and that's fine. You'll still have to subset it down to the right ones either way, so everything else will follow the same afterward. Okay, you'll just don't need to go open data year one. You can just do list.files. We still have to subset it down though, and your subsetting will be slightly different because you'll have different files in your folder, but you'll be able to figure it out. Okay, so yeah, this was what was in chat is said I could assign to files in year one. I could assign this list.files command. If I do this, files in year one looks like this, right? It contains the exact names list.files produced. Now, how would I modify this statement here so that I have the station data, not the status data? I do have the trip data, I do have the weather data, and I don't have readme.txt. How can I make it so files in year one doesn't have those elements? So files in year one here is just a character vector. It's just a bunch of text. How would I make this character vector not have those things? Okay, that would be one step, is I could take the CSV ones. If I take only the ones that have .csv at the end, that does get rid of readme. All right. So if I do that, and do you have an idea how to do that? I'm going to guess no, because I haven't taught that in the class yet. But if you do, good on you for being ahead.
No, I don't.
Yeah, that's great. Yeah, that's fine. I'm teaching that on Wednesday. So we'll get there. I can give you a preview, though. So if I want to do that, I could say something like files in year one, string subset it, and say ends in .csv. Right, I haven't loaded that. So one thing I would need to do is I'd have to load the stringr package, which I have not introduced in this class yet, but I will on Wednesday. And then that would be a way to subset it down to only be the ones that have CSV at the end. This is a thing called regular expressions we're going to spend most of Wednesday on. Okay. So here's a quick question. I'll get Gail's here in a second. Then when I list files, I'll get character 0 back instead of the files. So you're just doing this list files right here and you get 0?
Yeah, I've set my working directory a couple times and I think I'm in the right file.
Oh, so you set your working directory. So that might be the, so it's currently looking, so Gitwd and is your get working directory open data year one?
I guess it would be the file that open data year one is in.
So the file, the folder it's in, or?
Yeah, the folder it's in.
Okay, but so can you give me the exact result in chat that you have with Gitwd and the exact result from running list files immediately afterward?
Maybe.
Yeah, let's see. As far as Gail says here in the one above it, is one way we could do that is with direct numeric subsetting, which is absolutely true. So if we look at files at year one, what we want is the first, the third, and the fourth elements. So we don't want the second and the fifth elements. Well, you could actually just directly manually subset that and say, get rid of the second thing, get rid of the fifth thing, and that would give me the exact elements that I want. So if you're in a situation where your directory is never going to have files change in any way, you're not going to have additional files added or something like that, this will work perfectly for you, which is the default sort of answer for this. Okay, so this says Gitwd list.files. So
It's
put a
not very-
period. Put a period in front of that slash there on list.files.
That files. I still get character 0.
Because if I don't have a period in front of it, I get character 0. And if I put a period in front of it, I should get that. So
I can keep playing with it, but
yeah, no, it's okay. We'll get this. So the question is, so remove the period and the slash, so it's just open data year 1.
okay.
And if do you still get character 0?
Yes.
Okay. Browse to that folder on your computer and make sure it's got shit in it.
Browse.
As in, you
Okay.
can literally copy that directory path
Right.
you've got, yeah, and open a window and find it, and then see if it's got the files in it. We will not let the computer win.
Not good at doing that part fast.
Oh, that's fine. Like I said, it's a short homework. We're not in a hurry here.
Is browse lowercase?
So you can see the files?
No, I'm struggling using browse.
Oh. Yeah, I'll just be able to pop open. Let's see, you've got it in documents. You could just copy that right into your path up here, exactly what you posted in
The
path, like just paste that straight out. I don't know if that's what you have it on 508 like that, but if you just
right.
that should bring it up.
It
Or
should,
literally,
but it says unexpected input. Wait, no, I'm misspelling things now.
yeah, and if you do the Gitwd and R, you can grab the path exactly from here to copy it and paste it straight into the Explorer window, and that ought to do get you right there.
The backslashes are what get me.
Oh, they don't have to be the backslash. So the forward slash, this is the dumb thing about Windows.
Okay.
It allows forward slashes. It just converts them to backslashes, and R doesn't like the backslashes. So Windows is happy. So if you paste it in, see what the forward slash is, you hit enter, it still works. It just converts into backslash.
Okay. Every time I do this, I get an error.
Oh, don't use browser. I'm literally mean using your Windows Explorer.
Oh yeah, I know I've done that. I've copied that address a few times. Okay.
So are you to this window?
Yes. Sorry,
And
I've been there for a while.
oh yeah, and in Open Data Year 1, can you see the files?
Yeah.
So, and it's the exact same directory location here that you see when you're doing Gitwd here.
Yes.
Yet list.files has character 0.
Correct.
That fascinates me. Okay, this is curious enough to me. We are going to, would you mind screen sharing?
Sure.
Here, let me, I have to take some seconds. I gotta go activate it. Where's the permissions? Share. And then screen share, sharing all participants. Okay, you can screen share. So you don't mind people seeing your screen because it's probably recording.
Okay, so here's my directory, and then
Okay. Yeah, pop up the window. Let me. Okay, I see exactly what your problem is.
Okay.
So the thing is you don't actually have an Open Data Year 1 folder. You have an Open Data Year 1 zip file.
Okay.
So what you need to do is right-click that and click Extract All. Extract, yeah, just hit the top right. Okay. Can you right-click and drag it actually to the location? So, or yeah, hit Extract All with
Okay.
left click. What is it? Okay, now go to the top right where it says Extract All. So just up a little bit more.
Ah.
Okay. Press that. Is that what this thing has to do? Yeah, press that. Is it doing anything?
It's
What is it doing? I've never had
not.
this interface before. So okay, just double click that.
It's,
Okay. Now what you can do is you can literally highlight all of those things. So
oh, I found the extract all other windows coming to my other screen.
oh, okay.
That wasn't
Yeah, if you
right.
just extract that then to Open Data Year 1 in the main in this folder. So yeah, there it is. Okay, you see Open Data Year 1 now?
Yes. Okay.
Okay. Now go back over to there and run list files.
Ah.
Okay,
Okay.
we're in business.
Stop sharing my screen. There we go. Thank you. Sorry, guys.
Absolutely. Now, we will always solve these things. So, yes, that is the burden of having the problem, though, is that then you have to tolerate my unwillingness to continue without the problem being solved. So, but now we're good. Okay, so, yeah, that's the thing. It's also one reason that it's important to show something like that is that, you know, who knows who else is going to like be in that situation, because you know, if I do list.files here, somebody's going to see like Open Data Year 1 here and be like, why can't I get into it? It's like, well, honestly, it's just that it's a zip file and R can't directly browse into them. Interesting enough, R has a built-in unzip. So you can technically use unzip to decompress the file directly. So theoretically, I could have put code in there that would directly unzip the thing and take care of that for you. But, you know, I forget to do this. Anyway, so gonna delete some of this stuff. So this is one option here that was what Gail, I think, provided earlier, is we can basically just get rid of the second and the fifth ones. So we could do that, and I'll show you, we could make it so it looks like this. We could do it all in one step. So essentially we get the list.files Open Data Year 1, and then immediately subset it to remove the second and fifth, which gives us that, and then we could assign it to files in Year 1. An alternative method, if you were worried about the contents of the directory like ever changing, thus messing up this file, we could do something based on like this string subset command here. I could say something like, instead, take the files in Open Data Year 1 and subset it to the ones that are, in this case, I said that end with CSV. But you could instead say something like, just give me the ones that contain the words station, trip, or weather. And that would subset it down to the elements that contain the words station, trip, or weather. This is a thing called regular expressions we're going to cover on Wednesday. These two methods would give you exactly the same result. So you can use either one. Okay. We'll cover this on Wednesday. Okay. So now we got files in Year 1. So what we want to do is we want to read these CSV files into data frames that will be stored in a list called our data list. Okay. So I provided the code. I don't need you to figure these things out. To pre-allocate an empty list of length equal to the number of files in Year 1. Okay, so to be clear what's going on, length files in Year 1 is the number 3. Files in Year 1 is a length 3 character vector. So saying vector of type list 3 creates a data list that looks like this. Okay, so I've pre-allocated a length 3 empty list so we can stuff our files in. Okay, so next, we would like the names of these list entries to be simpler than just the file names. For example, we would like 2015 station data.csv to be read into an element called just station data. Trip data CSV should be read into just trip data, and so on. Okay? And so weather data will just be weather data. So what we want to do is let's make a vector of the names before we assign them to the list. So let's make a new vector called data list names, okay, which is going to come up with the names for these objects that are in files in year 1, but we're going to assign new shorter named objects. Okay, so if what we have is files in year 1, 2015 station data.csv, 2015 trip data.csv, 2015 weather data.csv, and we only want station data, trip data, and weather data, what can I do to files in year 1 to make that happen? You remember different functions we can use to get rid of, say, 2015 underscore and .csv? We've used 1 or 2 so far. Any ideas? So those ones where everybody just turns their camera off and runs away. They're like, he can't outwait us. Joke's on you. I have nowhere to be.
I am completely guessing because I don't know. But is it the string subset?
String sub would be the way to go. String subset is slightly different. I just used string subset up here, and it is unfortunately confusingly similar to string sub. So you're probably thinking of string sub. And the answer to that is yes. Do you remember how to use string sub?
No. I was going based off the fact that you said we've used it today.
Oh, yeah. No, string sub is one we used a couple times, also known as substring. But it'll get us there. But does everyone remember how to use it? We used it in the homework, the last homework, when we were figuring out which precincts are in Seattle. Do you remember that? Anybody? It's 2 weeks ago. I hope so. Unless you just completely shut it out of your mind permanently because that was what your experience with that homework was like, which I also understand. So how did we test to see whether, yeah, here we go. String sub, a vector, it starts at 1, it ends at 5, and then repeat again for the last CSV part. Okay, so this is a sort of an interesting one. So what this says here is, so I'm assuming if we use the exact code you've done, we're going to take this vector and we say 1 to 5. So what this will do is this is going to say, give me the 1st through 5th characters of each element of this character vector, which is 2015 underscore, which we want to get rid of, right? So if what we want to do, though, is not to keep those things or display those things, but rather to specifically remove them, how could you modify this exact statement here so it just cuts off those ones?
You can start from the 6th one and end it right before this csv.csv. So that would be
exactly. So there's a neat thing in string sub, which I only briefly, I think I maybe mentioned earlier in the class, is so you can count positive from the beginning of a string, you can count negative from the back of a string. If I say go from 6 to -1, it will give me everything from the 6th character from the front to the 1st character from the end, which is just the end of the string. Well, logically, we can start chopping letters off. If I go -2, it cuts off the last character. -3 cuts off another one. -4 cuts off another one. -5 finally deletes the period 2. So the .csv, the last 4 characters, can be deleted by saying -5. So we're actually saying here, for every one of these, start 6 in. So as she suggested, 1, 2, 3, 4, 5. So this is the 6th character at S. We're going to begin with that one. Then the thing I added on here is we're going to start at 1 character back, 2, 3, 4, 5. So it cuts off the .csv. So this is one way that we can use string sub to get rid of things we don't want, so long as what we want to get rid of is always a fixed size at the beginning or at the end of a string. So I could assign this to data list names, and it now looks like that. To give you an equivalent using techniques you have not learned, but you will learn on Wednesday, I could do this in a slightly more flexible way. Instead of string sub, I could say string remove. Yeah, let's go string remove all. String remove all. What I want to remove is I want to remove any instance of 2015 underscore or .csv. Actually, I can just do string remove. No, I gotta do string removal. Okay. Think about that one for a minute. There we go. So this is exactly equivalent to this. They're just 2 different ways to go about it. Most people at this stage are probably much more comfortable doing something like this and don't know what sort of bizarre magic is occurring right here, but you're going to learn this bizarre magic in a couple days, so it's okay. So here's the thing. Gail asks, is there a way to save station data, omit the underscore, and replace with a space? Yeah, we absolutely could. So if you wanted to remove just the underscores and replace them with spaces, you could actually do something like that, which says, I would like to replace all instances in data list names of an underscore with a space. So string replace all will do it across all of them. So if I do just string replace, in this case, it's going to give me the exact same result. But string replace only replaces the first thing it encounters that matches this pattern, which is why I had to use string remove all up here, I think, because if I don't, it's going to remove the 2015s and stop looking and not also remove the .csvs. But if I do string remove all, it removes both of them. So I tend to be using string replace all and string remove all the time. We're going to see these again on Wednesday, but these are powerful for messing with text. There is a good reason right now to not remove those underscores and replace them with spaces, and that is that it is often awkward to work with spaces in object names in R, and so I'm going to leave them in. But if you want to remove them and work without them, go right ahead. It just might be a little bit awkward if we have to use like a $ operator or something later, because then you have to put the names in backticks and stuff. Okay. Anyway, those are equivalent ways to get the exact same thing. Okay, so now we got data list names. Questions so far? Just building up some foundation stuff to write a loop. Okay. So if I want to assign data list names as the names of the data list elements, how do I write that statement? close. The names function just has to be moved slightly. So what names as a function does is names essentially accesses a meta element of an object, which you can use to either extract things or assign things to it, kind of the way subsetting operators work. So like subsetting, if we want to assign to a specific element of data list, where would we put the subsetting operator? Yeah, but we put it on the left side of the assignment, right? It's the same thing with the names. So what we're going to say is we want to assign to the names of data list some data list names. So right now, data list looks like this. If I assign some names to it, it now looks like this. The idea is that names is a function that actually accesses like a special slot in the object where its names are contained. So this is kind of like putting a subsetting operator on data list and then assigning something to what you're subsetting. It's actually a really weird thing to assign something to a function. Probably haven't been thinking about it this way, but you've been doing it the whole time. Every time you assign something to a subsetting operator, you're really assigning to a function. Does that make sense?
I think so.
Okay. It's okay if it does not, or if you need any more explanation. Okay. So all of this so far has just been to get us to essentially this point with a list that has some empty spaces in it, which we want to stuff some things into. Okay. Now comes the hard part. We have an empty list. We know we have some files. What we want to do now is we want to write a for loop that will use the read CSV function from the reader package and read in each of the CSV files once at a time, rather, and assign it to its corresponding entry in data list. Okay, so this is actually takes very little code to do, but it's something very hard to write if you've never written a loop before. So we're going to kind of walk through it fairly carefully and kind of run it a couple times and explain what's going on. Okay, so if you want to write a for loop, how do you start a for loop? What is the structure of a for loop? What's a for loop always start with? Yeah, not a trick question. It begins with for, right? So we say for. Yeah, so we have for. And you'll notice here in our studio, it actually like wants to like show us how to write a for statement, which is kind of fun like that. So we have for. Typically, what we do with a for loop then is we'd say something like for parentheses. And what do we normally put in those parentheses? Usually about 3 pieces in here. What are those things usually? What's the first thing you always see?
I have a slightly unrelated question.
Sure, yeah.
So I've been trying to get that, like, you know, the pop-up screen where it kind of tells you how to do the code.
Yeah.
For some reason, like I think when I type for by itself, it pops up. But then as soon as I start to put like the first parenthesis, it just goes away and then
Yeah.
But that's normal. Like it doesn't stay up past once you start putting the parentheses.
No, so what this actually is this is the autocomplete interface. And so what this thing is showing right here is something referred to as a snippet. And the snippet here allows you to press the button here, like, for instance, if I hit tab right now or I click on it, it will insert this full structure for writing a loop. And then that just saves you maybe some thought and some time. So for variable in some vector, it adds the squiggly brackets. It's a convenience, but it's basically autocomplete. As soon as you open the parenthesis there, it's one more character than the autocomplete has in it. So it just drops it from the interface. It'd be just the same things if I typed like for here and then I immediately typed C. I'd lose the snippet one, or maybe I'll do do like a form or forp, whatever, it's going to drop it off. Yeah.
Okay. That's so helpful that it can just kind of type it out like that. Okay, thank you.
Yeah, and you can actually make your own snippets like this too, is an interesting thing. Our studio allows you to make your own and add them to it. So if it's some common thing you like to write, you could add some autocomplete text for it and have it automatically generate like sets of stuff like this. Be good for making snippets for like apply functions. So I think it already has, yeah, snippets for apply functions and stuff built in. Pretty cool stuff. Anyway. As I was saying, I'm not going to let people get away with not providing me things. So what do you next normally have inside a for loop? Yeah, for element in list, okay, or for I in one to data list, or I in something. All of these are excellent answers that are correct, okay? So I is a conventional iterator, so we can do that if we want. We could say for I in, and then anything we want. It's going to be some list. Here, I specifically say up here, just to make it kind of easy to work with, I'm going to say, let's do a sequence along. So if you remember, if I say sequence along files in year 1, that's just the numbers 1, 2, and 3. Files in year 1 is a length 3 character vector. If you run sequence along it, it gives me the numbers 1, 2, 3. I'm gonna say sequence along files in year 1 as a sort of nice way to run across the numbers 1, 2, 3. That way, if files in year 1 for some reason changed in size, everything else would change, say, the number of iterations and everything. It's kind of a nice convention to get used to doing. This is identical to doing for I in 1 to 3, though. Okay. Next thing we normally do with a for loop is if we want to run code inside the for loop along multiple lines, we're going to need some squigglies. So squiggly brackets, which sitting over to the right of the P above your like quotes key, below your equals key, you will find squigglies. We will squiggle, I will hit enter, and then code will go inside of here. So, few different ways we can attack this, right? So we have a mildly complicated thing we want to do. What we essentially want to do is read in a particular file on our computer, which is in a subfolder, read it in using read CSV and assign it to the appropriate location in data list. So we can break it up into multiple steps. How about we begin with reading the file in? So how would we normally read a CSV file in R? The text directly above this chunk gives you some ideas, but I'm making people type things. Folks waiting for those gimme answers to post in the chat. Here's your time. Want to read in a CSV file? Yeah, read CSV. And what package is read CSV on? Read underscore CSV, that is. Because we need to make sure, yep, I'll take it. Library reader. So we need to load library reader to make sure we can use read CSV a little bit after. So I'm going to say library reader, make sure it loads. Now I'm going to say read underscore CSV. Okay. So read underscore CSV takes a file name as its first argument. So we need to give it a file name. So remember that our files, our actual file names are in, right, files in year 1. So I'll just display it down here to show you. It's things like 2015 station data.csv, 2015 trip data, 2015 weather data.csv. If I want this loop to, on each iteration, load a different one of these, how might I specify that in the first argument of read CSV? Anyone have an idea? I like it. Read CSV, files in year 1, and then subset it to the current iteration. So this says, I'm going to say read CSV, files in year one. Specifically, I don't want all the elements, but I only want the element corresponding to our current iteration, because right, in our first iteration, I is going to be the number 1. The reason for that, of course, is because this is the numbers 1, 2, 3. So in our first iteration, this is going to be 1. So this would say read CSV, specifically files in year 1, subset to its first element. That is, it's going to run that command right there, get 2015 station data.csv. Great. So if I say read CSV files in year 1, and I run that, it's going to give me an error. It's going to say that does not exist in my current working directory. And why is that? Why can't I run that files in year 1?
Because earlier when we extracted the files in year 1, we went one level lower.
Exactly. They're not in this folder at all. So what we need to do is we need to browse one folder deeper that is in the Open Data Year 1 folder to get that path. So what would I need to do to convert files in year 1 like this to the full file path, right? Think about what that full file path is. That full file path is basically Open Data Year 1 / that, okay? Well, what would I have to do to convert this statement here to make it so it produces this instead? The // will still look in the same directory. It won't help us. How could I tell this to browse into that folder and then get that file? It's actually not a tricky method. It's actually a brute force method. Can you think of a way we could do it? Yeah, that's the general idea. You're both right. We can just paste that text on. You can take the exact statement we have here. So as an example, I'm going to use the one outside of the loop and say, okay, I want this thing, 2015 station.csv, but I want this text before it. So I can just say, well, let's paste together. You can use paste or paste 0. I usually use paste 0. Here, files in year 1. So what this is going to do, and you need the /, okay? This is just generating that text, Open Data Year 1 / 2015 station data.csv. If I run this line, it's going to dump that into my console, having successfully read in the file, so I know it works. So all we did is we had R assemble some text that we normally probably would have just had to manually type ourselves. Okay, so if I take this, paste here, replace it here, replace this with an I. So in theory, now if I run this loop, it should read in every single one of the files in Open Data Year 1 that's in files in year 1. So if I run this loop, you'll see the output has this column specification thing indicating it read in a data frame, a different data frame here, a third data frame here, but it just spit them out into our console because we haven't assigned them to anything. This tells us, okay, we're successfully accessing and reading the files in our loop, but we're just dumping them into the console essentially. So the next part of this is, how do I capture the output from each one of these read CSV statements and assign it to the correct location in our data list? What do I need to add to this to make it save what we're doing? You can say this in the abstract or give me actual code. Okay, I'm getting an error in. Let me paste yours in and see if it looks like mine. That looks, you appear to be missing a parenthesis right here at the end.
Got it. Thanks.
Yep. Here's a good one. So Sam here has suggested what we do is we augment our loop with a assignment to data list. Okay, so this would say here what we want to do is for every iteration of our loop, we will read in that single data file, and then we will assign it to data list in this particular element. Okay, let's see what this does. So I'm going to look at data list right now. Data list looks like that. Let's run that. Now notice you see something interesting. Number of items to replace is not a multiple of replacement length. Number of items to replace is not a multiple of replacement length. And what does data list now look like? Data list looks like something weird. Okay, we have run into one of the great banes of the R program. What do we think is about this that is just slightly off? Does anyone have an intuition for this? Doesn't necessarily have to be a logical explanation. But when you're working with a list and you're doing subsetting and something gets weird, what does it usually do to? It's okay that it's putting the actual data in there, but it's putting it in a weird way, isn't it? What it did is it put the first column of the first data frame, the first data set, into slot 1, its second column into slot 2, its third column into slot 3, and then it discarded all the remaining columns and the next 2 data frames we read in from the files. So it's actually assigning them weird. So why might it be assigning them strangely to data list? It's not assigning the whole data frames that are being read in to the individual elements of data list. Instead, it's assigning the columns one by one in. So the thing about this is an oddity in R that I've talked about back in like week 4. If you want to assign, say, an entire element of something to a slot in a list, you probably don't want to use single brackets. As Gail suggests, you probably want to use double brackets, because the double brackets subset down to a single actual slot in the list. If I do this instead, we don't get the funny errors. You get the column specifications without the additional errors we said before. And now if I look at data list contains its first element is a tibble 54 by 7, another one, which is 142,846 rows by 12 columns, and a 366 by 21, which is daily temperatures, basically. If I go and hit, say, structure data list, we now see this. We see a station data slot containing an ID, name, terminal, latitude, longitude, number of bikes it can dock, and when that station went online. And then the next data frame is our trip data, which contains trip ID, start time, stop time, bike ID, trip duration, what station we came from, what station we went to, the ID of those stations, the type of user, their gender, their birth year, and then lastly, weather data by day for max temperature, min temperature, and all that. This looks like what our output should be. The difference here is just single versus double brackets. Typically, when you want to do something like read in a bunch of data frames and assign them to slots in a list, you want to assign to double brackets instead of single brackets. If instead what you wanted to do is say read in a data frame, like a single data frame, and assign each one of its columns to a different element of a list, you would probably use single brackets and assign the data frame to it. And then it would assign across multiple elements of the list. That's a rare operation to want to do, but it's what the single brackets are for with a list. Real weird, huh? Okay. Questions about that? Weirdness about this. This is the entire loop to do it. And the neat thing here is if instead we had 10,000 CSV files in that folder, we wouldn't have to edit a single line of this code. It would just work. This is why iterative operations are nice. They can be a pain to understand and figure out how to write, but they're very powerful. Okay, let's show you an alternate way to do this that doesn't involve writing a loop. So, if I want to create a list of things as a result of iterating over something, what function could I use instead of running a loop? What could I use as a function to generate a list of what I want? Does anyone have an idea? Do we remember this from last lecture? Tried to emphasize loops suck, and there's an entirely alternate system of iterative operations. Exactly, Gail's got it. We could use apply function families, specifically lapply, suggested in chat. So the idea behind the apply family is they look or they operate a lot like loops, but they don't look like a loop because they take care of all of the most painful things of loops for you in the background, but they require you to run a function. The thing is, we're actually running a function here, so it's going to be real easy to lapply this. So what we're going to do is we're going to run an lapply. Now, this might be hard to think about exactly what we're going to do. We're going to lapply in this case. I want to show you something slightly more powerful. Let's not iterate over the exact same thing as our loop. If you remember, what we iterated over on our loop was actually the numbers 1, 2, 3. Why don't instead we iterate over the actual file names, but specifically, why don't we iterate over that full file path? So if I say paste together open data year 1 and files in year 1, it's going to generate all 3 of the file paths that we want. Okay, so if we've got this, a list of all the file paths we want, does anyone have an idea how we could make lapply use these file paths to run read CSV one time on each file path? If you know, be fast to write. If you don't, it's going to blow your mind. I'm just going to call this file paths. Does anyone want to take a stab at how we might do this? Remember how apply statements work. You give them something to iterate over and then a function to run on each element of that thing. So first thing, what are we iterating over?
File paths.
Yeah, we're iterating over file paths. Okay. Next thing we got to give it is we have to give it a function to run. What function are we going to run on those file paths? Read CSV. I am not fucking kidding. That does it. Okay. So that is how you do it with the with an lapply. You give it the set of file paths, you tell it you want to read CSV, and it's going to spit out all the stuff we just did with that loop. Okay. They're not named for us because we'll have to add the names ourselves to them. But why don't we do that too? I can say, let's add some names, set names. What we called it? We called it data list names. Data list names, assign that data list. And you just did all of those chunks in one call, right? So that will do the job. Yeah, okay. I got to teach you loops. They're real useful, they're powerful, they're good to know about, but there is no world in which this is not a superior way to perform the exact same statement. Okay. To simplify this, if you're not familiar with the set names function, it's exactly equivalent to going that. So I could do it in 3 lines. Okay. So do either one, do whichever one makes sense to you. I will say that for your sanity in the long term with R, learning how to do things this way will benefit you greatly. So I did for the first maybe 3 years, 4 years, probably of steady R work that I was doing, I resisted and was confused by lapply like apply based functions, and I did a lot of loops. Okay, so all my code written after that is much better than the code written in that period, right? Yeah, that's the exact thing I had before, I think. Error that it's incomplete. So let me see if what happens if I set names, file paths, read CSV. That works for me. So the question would be to check, oh, yeah, no, there's a missing parenthesis on the right side. Yeah, just an unbalanced parenthesis.
I did not mean to send all of that.
Oh,
but
that's fine. That's actually useful to me.
I got another error message that says error in set names.
Okay. Yeah.
Argument NM is missing with no default.
Let's see if I found that. Oh, do you have, are you using what I wrote up your file paths, but your files are actually in the same folder as your R&D?
I actually changed it where I did the folder.
Oh, okay. And then you're getting argument NM is missing. So L plus 5 plus read CSV, you shouldn't need. Oh, no, that's what, yeah, you don't have, so you also would need the data list names right here and set names. That should do it. Because you've done set names, but haven't provided the names to set, I think.
That did it. Thanks.
Okay. Cool. Yeah. Okay, so that's 2 ways to do iterative reading in like files. Loops, like you can see, that is drastically more code because the actual like loop portion of this here is completely replicated in full by this single lapply statement. The rest of the stuff around the lapply here is just making our life a little easier and redoing some work we did up higher up for the pre-allocation of the list. No pre-allocation is necessary. It does the allocation on the fly. This is sort of a better way to do it, in my opinion. So I like this. Okay. You can do either one in the homework. Yeah. I used to just require people to do the loop, but it's one of those things where I'm like, I know loops can be traumatic to people. It's nice to be able to know how to write them. But in R, most of the time you don't have to, and it's better to discourage people from writing loops. In fact, some of the really premier names in the R programming world are rapidly getting to the point where they're saying the textbooks for R shouldn't even include loops at all. Like just say, don't even show them because it's just, they don't bring anything to the table. And I'm starting to lean that way, even though I'm kind of old school. Okay. So if you have any more questions about that, let me know, or if anything's not working. We only have one little thing we want to fix next, and then we'll be done. Okay. So the next one says, run structure on data list and look at how the variables came in from using read CSV. Okay, Chuck, I'll do that. Structure, data list. Okay, there's a lot of them. I kind of glanced at them earlier. We see stuff like station data. The first data frame contains IDs. It contains names of the stations, terminal, particular station sort of like ID numbers, their latitude and longitude. Theoretically, you could use something like this for mapping. You could actually look at the flows of bikes place to place over time. Okay, this stuff all looks pretty good to me. So we go to the next one, and I see in the trip data, got trip IDs, but then I see a start time. I see it was read in as character data, and when I glance at it like this, That looks to me like a nicely formatted date. It probably shouldn't be character. It should instead be a date time so that I can do date time stuff with it, which we're going to do in the second half of this homework. So I might want to convert the trip data column start time and stop time into date time objects instead, which is something else we're going to talk about on Wednesday. Okay. We also have the same thing in weather data, where we have a date column, but it is just character data instead of a date object. So we might want to convert it to a date object. Okay. There's another one in here that we can't see from here, but I'll do a cross tabulation of in a bit, where our gender column here has a lot of missing values related to another column in our data set, and we'll want to clean it up too. So I guess that's actually what I have listed first. So even though I talked about the POSIX time, let's mess with gender first. Okay. So if I say, and notice this, this is how you're going to be accessing individual data frames in this assignment. So each data frame we're working with is an element of our overall data list. So if I want to get at the trip data, I have to say, go into data list, subset the trip data frame, and that will spit out the trip data frame. This is equivalent to saying this. $ trip data would also get us the exact same thing. These are equivalent ways to subset it. You get the same thing. Technically speaking, you could do it this way. I wouldn't recommend it, but you could say data list number 2, because trip data is the second element of data list, and that would get you the same thing. These all work, but for reasons we're going to see next week's homework, I highly recommend using the standard input text-based subsetting, because this will be easier to use when you write a function later. Okay, so we've got trip data. Now what I want to see here is it says we need to patch up some missing values for gender in data list trip data. So I can say, let's take data list trip data, type it in, and look at gender. Now to do that, if I want to look at it, I'm gonna have to load dplyr, which I haven't loaded yet. I've got dplyr loaded. Now I can look at gender. You'll see here what gender has is a certain number of female writers, male writers, other writers, and then 55,486 NA values. Okay, it's like, okay, we got these NAs. Now the thing is it turns out, and I'm just sort of feeding you this information up here, it turns out that NAs were recorded for people who just weren't regular subscribers to the system. If you were somebody who didn't have like an ID in the system, they didn't record it. But if you have an actual ID, they just record your demographic information. So if I look here at, now it won't populate them for me. What's the name of the field? User type. So if I go, let's do a cross tabulation of gender by user type. And what we see is that they accurately record, or I shouldn't say accurately, they just record gender field for anyone who is an annual member of Pronto Bike Share. And every single NA is just somebody who's a short-term pass holder. Okay, so basically what it is they just didn't record data on those short-term pass holders. So what we want to do is probably just replace all of the NAs over here for short-term pass holders, replace them with an unknown for those people because we don't know anything about them. Okay, so let's do that. So first thing we'll do is, well, now I say fixed date times converted. Let's do the gender one first because we're talking about it. So if I want to take data list trip data, and then I want to modify the variable to replace those NAs for short-term pass holders with the word unknown, how would I go about doing it? How would I modify that column in my data set? Baby steps, what's the function? So we could use an if else, but typically what would we use if else inside of first? In fact, we will use an if else. It's probably the easiest way. So if we're working with a data frame, yeah, we're probably going to use that if else, but we're going to use it inside of a mutate, because the mutate will allow us to pipe a data frame in and apply those changes to the column within the data frame sort of in place. Okay, so we're going to say we want to mutate. Then what we want to do is we want to modify the gender variable in some way. When we want to modify a variable, what do we do in R? What would be my syntax for modifying gender here? We could use recode. Technically speaking, it's not a factor at the moment. Recode would make it a factor. I'm just saying, if we want to modify gender, what do I type next inside this mutate? We could use if else, so I'm fine with the if else we're going to use. But before I type if else, what do I got to write? What is the syntax for mutate? Data comes first, but we've done that already. By piping in data list trip data, that's actually made it the first argument to mutate. So what's my next argument? What am I going to write here? What do we usually write in a mutate statement? Yeah, we write something like gender, right? We're going to modify the gender column. And so we're going to say gender equals something. Because in R, we create variables and modify them using the exact same syntax, because R is a destructive language. R just overwrites things when you want to change them. So to modify something, you create a new variable with the same name, it overwrites it. Okay. I'd like to if else for before as a way to modify this. We're going to say gender is equal to if else. So what logical statement would we use here if we want to assign a value, let's say unknown, to gender whenever the user type is short-term pass holder, but otherwise leave it alone? What might that statement look like? So remember, with if else, you give it what? What does if else take as a first argument? Oh, I like it. Let's see. Yes, if user type is short-term pass holder, user type equals short-term pass holder, return unknown, otherwise return the original value of gender. I think that looks flawless to me. So no error here. And then I'm going to see what happens if I do this count statement again. Yeah, okay. That looks good to me. So what we've done here, what that code provided does is it looks down essentially every row of the data frame. Anytime it sees the user type as short-term pass holder, it assigns unknown to gender regardless of what its old value was. In this case, they happen to all be NAs, but they could have been anything else. Then if it is not user type short-term pass holder, thus its annual member, it just leaves it its original value. It goes and reads the original one, assigns it. And this gives us the same values for all of these because they aren't short-term pass holders. But for the short-term pass holders, it's replaced all the NAs with unknown. Okay? It's a really clean and simple way to replace something based on a quick logical value test. Okay, I like that. So what we're going to go ahead and do is, again, R is a destructive language. If we want to change our trip data to have this change in it, we're going to have to assign the value back to it. So we are treating this entire thing just like a normal object name because to R it basically is. So what we're saying here is we take our trip data, perform this operation, and then assign it back to trip data, thus making the change permanent. Okay. We got one more thing to do. Next one, I'm going to put it in its own chunk. Next thing, we want to fix any dates and times in any of the data sets to be better data types. So if I look at data list, station data, honestly, there's one that's technically a date here. I don't care about it. We're not going to use it, so I'm going to skip it. There's nothing in station data we want to mess with. But trip data has a start time and a stop time that I would like to convert into date time objects. And then the weather data has a date column I think I want to change to. I don't remember if I think I used the date column in weather. Okay. So if I have data list, trip data. So here's a question chat. Get another error message for unexpected symbol. Okay, you're missing a quote in trip data, the second one in data list subset. Okay. Okay. So right here we got trip data. So if what I want to do is I want to convert, say I wanted to convert just the like start time column to a date time. So I'm going to really quickly go, be easier if I go to glimpse right here so you can see it. Okay. So if I want to modify start time to be a date time object, we did some fancy stuff with LubriDate very briefly, I think in week 5, but I'll give you a bone here. Now, we could modify start time and modify stop time separately, but if I wanted to modify both those columns in the same way simultaneously, how might I do that? What's a thing I could do to operate over multiple columns at once in sort of a dplyr pipe chain? Does anybody remember? Did some of these in my examples on Wednesday. What's a helper? Well, we could do it with like an S-apply or something, but it'd be a little harder. What I want to do is something in the pipe chain. There's a helper that can go inside of mutate that lets us do apply style things across multiple columns, but without having to go full bore and write an S-apply or an L-apply. You remember what it is, or anybody? Not call names. Call names can be useful. In this case, if you're doing an S-apply or an L-apply. But do you remember something that goes inside mutate to make mutate operate over multiple columns? I've used it a few times. It's a remarkably normal sounding word for a function. Well, if you want to mutate something across a bunch of columns, what's the function? Everybody remember? It's literally across. So do you remember me using this a couple times? So what I want to do is I want to mutate across multiple columns. Since nobody came up with it too fast, I'll just show you the syntax. It's a little bit complicated, but the idea here is normally when you write a mutate, you say like, I'm going to make a column named this equal to this thing over here. Across has a slightly different syntax. Across just assumes you want to overwrite the columns you're working with, and you just provide it with the names of the columns you want to do that to. In this case, those columns are start time, and stop time. So we're going to say we're going to do something to both of these. And then you might remember the funky syntax I'm about to use. This is saying here, I want to start time and stop time, kind of like how we apply and we put the things we want to apply to first. What we want to do is take start time and stop time, and then we want to do something to them, which is signified by this tilde. Specifically, what we want to do is we want to convert them into a date time object. Well, the thing we want to convert them to is, do you remember what the functions in LubriDate look like? So if I load up LubriDate, do we remember what, let me get a glimpse back up here really fast. So you remember what the function would be if you want to convert start time, which is in the format of month, day, year, hour, minute, into a date and time using LuberDate? Do you remember these intuitively named functions from LuberDate for converting dates? I'll show you. So if we've got, I keep getting rid of my glimpse there. That's all handy. I should have put it down here. There we go. Okay. So in LuberDate, we got functions that look like this. MDY_HM. If I give the text like this to MDYHM, LuberDate will spit out 2014-10-13-103100 UTC. So what MDYHM does is it takes text arbitrarily formatted as month, day, year, hour, minute, and converts it to R's native time date format. So if instead this was like day, month, year, which it isn't unless there's a 13th month I don't know about, it would flip this around appropriately. Okay. So what we can say here is I would like to encode start time and stop time using MDYHM. Technically speaking, if you don't have any additional arguments to give it, with a cross, you don't even have to put the tilde there. It will just work. And now start time, instead of being a character data column, it now says it is a POSIX CT time object for start time and stop time. We've essentially converted our data here into a proper date time object, which R knows how to do date time operations too. I can then assign this back to trip data, make the changes permanent. And then we have one last thing I want to do. We have an exact same thing sort of in the weather data. If I say weather data, glimpse, we have a date column. Okay. So if I start with the weather data, what do you think I would have to do? So here's the thing. Problem with mutate input can't subset columns that don't exist. Column start time doesn't exist. Can you give me your exact code that you have written? Like this, paste it in. That's the tilde. So if you have the tilde like this, you need to additionally add that. So you can either work without the tilde, or you can have tilde and then parentheses with a period. But it has to be either one of those forms. Sorry, I did it this way, which you haven't seen too much of because I didn't have to give it additional arguments, but it's equivalent to this form here.
Yeah, I didn't have a tilde.
Oh, and it still gives, oh, so here's yours right there. Okay, let me copy yours then and see. Yours is exactly equivalent to mine and works. So if you go and display data list trip data, does it look just like this? So these would be a little different, but does it display data?
It does. Oh, I think it only shows gender and user type from the code before.
Oh, so by any chance, do you have, do you have a count user type, gender, something like this, like here, that's assigned back to the original data, like here? Do you have it like there? In which case that's overriding that with the, yeah, okay, so then you're gonna have to reload the data too. So what you'll have to do, that's my bad if I did that operation down there. You can basically make sure you don't have like a count gender user type after like this line here.
Oh, okay.
Yeah, and then press run all chunks above right here. and that'll just rerun, reload all the data, and get you right back to where you are.
Okay, thanks.
Okay, make sure that works too before I continue on.
Okay, let's see.
Great. Okay, so now what we want to do is essentially the same operation on date in here, but date doesn't have the hour and the minute. So just guessing, if you have this format, month, day, year, what is the lubridate function to convert that? Yeah, it's MD1. Okay, so we got month, day, year formatted dates. So I can just say, convert them as a date, and the result is going to be a date object. Sign it back. And you're done. That's everything. So there's one tricky thing in this first part, which is figuring out the iterative way to load data in. The rest is kind of like conventional data manipulation tasks, but I try and make, at least show you something useful in here that is like using an across function and reminding you of the ability to change single values, even using a different column, using if else. So is all that working for everybody? And one thing I'll note, if you run this line, a line like this, where you mutate something into a date time and you run it a second time, it's going to replace all those values with NAs, because the MDY HM function, if you run it on something that's already a date time object, it will get very confused. And lubridate, for some reason, doesn't have built-in error checking to make sure something is not already a date time object, which is, in my opinion, the one stupid thing about the package. Because it's very common for people to run that line twice and then have it break. And then you have to reload the data from the start. I have no idea why they don't do something about that. Anyway, should be good. And if something's not working right, your first step should be to go to this button that says run all chunks above on the last one. Just rerun everything before, then run this chunk and make sure everything looks good. For your actual homework, I'd also recommend including things like, maybe some glimpse statements. Glimpse is nice because it just shows your data properly got formatted or something. You could use glimpse or head. Glimpse is probably better for most large data frames. You throw in a couple of those. That'll make it a little easier to make sure things kind of did what they were, not glimpse. That'll make it a little bit better. Stuff like that. Make it look good. Anybody got any other questions? If not, you can get out of here. I can get back to other work. The everlasting grind. Yeah, absolutely. I'll see folks on Wednesday for, in my opinion, one of the most important, fun, and useful lectures of the entire term with regular expressions.
Can I see one more time what came up for Glenn? Sorry, I'm still checking to see if this was done correctly.
Yeah, so they should look like DTTM objects, date times. And then for this date one, it should be a date object.
Mine is showing characters.
Okay. So have you run this and assigned it back to the trip data and then run glimpse?
Oh, let's see. I just did all the chunks ahead.
Mm-hmm. And then you'll have to rerun that same chunk if you ran all the prior ones.
Okay, let's see. I think I'm confusing myself.
That happens.
So I have it all in one chunk. I have like the library lubridate, then data list, trip data, mutate across, start time, stop time, MDY, HM, then data list, trip data, mutate date equals MDY date, and then I had data list. Oh wait, I think I was doing. Should I do trip data for Glimpse?
So yeah, this is just here to look at the trip data and make sure it looks good. And then I just went to another chunk for the weather data. You could do them all in one chunk if you want to, but yeah, you should do trip data glimpse if you want to check it out. And then you can just press the button in the top right to run them all. It'll break if you do it a second time like I just did, and then I have to rerun all the damn thing.
I see. So I was trying to, oh, okay. So start time DTTM, stop time DTTM. Okay. Yeah. That's what I'm looking for. Okay. Great. Thank you.
No problem. Okay, let's see. Somewhere here's a recording. There you go.